Hey everybody, 3.5 showing lines parallel coming your way. You may see some familiar postulates that you do need to write down. They're not the exact same, they're slightly different. And let's get into those. The very first thing I write down is going to be converse. What a converse is in an if-then statement. The converse is the statement formed by switching the hypothesis and the conclusion. So if you look at the statement down below, it says if you live in if you live in Sacramento, then you live in California. The converse to that is if you live in California, then you live in San Francisco. Notice that the converse may or may not be true. In that second one, it is not true. The converse is not true because if you live in California, you can live in other places besides Sacramento. You don't have to live in exactly Sacramento. I want you to write down all of this, the converse, the statement, and the statement's converse. It's just flip-flopping the hypothesis and the conclusion. All right. What I want you to do in this, it says write the converse statement of the true statement, then determine whether the converse is true. What I want you to do is looking at these two statements, switch this statement to a converse statement, and then tell me if it is true or not. All right, so the very first one, if two angles have the same measure, then the two angles are congruent. If we flip these around, okay, if the two angles are congruent, then the two angles have the same measure. And then what you ask yourself is that a true statement? So is it true that if two angles are congruent, then the two angles have the same measure? Is it true? Yes, it is true. You can put true underneath that first statement. So that converse in that one is going to be true. Second one, if angle 1 and angle 2 are right angles, then they are congruent. If I'm just going to simplify this a little bit. If angle 1 is congruent to angle 2, then they are right angles. Okay, and now ask yourself, so if angle 1 and angle 2 are congruent all the time, then they have to be right angles, and that is going to be false. They do not have to be right angles all the time. Sometimes they are congruent 37-degree angles, which are not right angles, or 134-degree angles. Maybe they are congruent at that point. So they do not have to always be 90 degrees. Okay, moving on. So we talked about corresponding angles postulate. We talked about alternate interior, alternate exterior, and same side interior. Now what we have is we have those converse postulates. And again, I want you to write these down. This one says, if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So if we know that in this diagram, angle 1 and angle 2, we know that those are corresponding angles. If we knew that those are corresponding angles are congruent, then M and N have to be parallel to each other. On the flip side, what our postulate said before was if we knew M and N are parallel, then we know 1 and 2 are congruent. Now it's the converse. If 1 and 2 are congruent, then M and N are parallel. Okay, so write that down. That also goes for the converse of the alternate interior angles, converse of alternate exterior, and converse of the same side interior angles theorem. Okay, again, if it is true for alternate interior that your alternate interior are congruent, then those lines have to be parallel. Same thing with alternate exterior. If the alternate exterior angles are congruent, then those two lines are parallel. Last one is the different one, kind of the odd duckling of it, the same side interior. If those are supplementary, then the two lines are parallel. So you need to know that those pieces of information to know that those two lines are parallel. So corresponding converse to corresponding angles, converse of alternate interior, converse of alternate exterior, and converse of same side interior angles. You need to know those converses to see if those lines are parallel. All right, so finish that one up. All right, so moving on. Now the question is going to be, can you conclude that line L and line M are parallel from, not form, from the following information, and explain. Okay, so what we know about angles from the past, okay, what we know about the corresponding angles, alternate interior, alternate exterior, and same side interior angles, and that we know the converses. See if you can figure out if it is true or not. Okay, I want you to try 1, 2, and 3. Be careful on number 3. Give her a shot. All right, so if we look at this very first one, it says that angle 3 is equal to angle 7. If we look at those two angles, do we know that L and M are parallel? Yes, we do. And our explanation is going to be the theorem that we know of. So because 3 and 7 are congruent, what type of angles are those? Those are corresponding angles, yes. So then we know what? If those two are equal, then the lines are parallel from the corresponding angles converse postulate. And I'm just going to write post on the end. Okay, so we know that those are corresponding angles, and because they are congruent, it is the converse postulate that we use. Make sure you know when to use each postulate. Second one, angle 2 is going to be congruent to angle 5. All right? I apologize, not congruent. They are going to be, angle 2 is 143 degrees, and angle 5 is 37 degrees. So how could we prove that these two lines are parallel? Okay, or so, can we prove it? And the answer to this one is going to also be yes. Now, how is that possible? Remember, we are making logical arguments as to why that is possible. Well, we know that if angle 2 is 143 degrees, we also know that angle 3 has to be 143 degrees. Okay? Now, we know that angle 3 has to be 143 degrees because those are vertical angles. Now, we cannot quite say right away that angle 2 and angle 6 are congruent to each other because we don't know quite yet that L and M are parallel. But we can say that angle 3 is congruent by the vertical angles postulate. So, we know that angle 3 is 143 degrees, and we know that angle 5 is 37 degrees. So if we took those two types of angles, if we had, what type of angles are those? Those are going to be your same side interior angles. So same side interior angles. And we know that if those are the same side interior angles, they must be supplementary in order for L and M to be parallel. So because 143 plus 37 is equal to 180 degrees, we can safely say the same side interior angles converse postulate. Okay, be careful. Again, your argument is not that 2 and 6 are the exact same, or that 2 and 7 are the exact same to begin with, because we don't know that yet. We don't know any information on 6, and we don't know any information on 7 to allow us to know that those are corresponding angles or alternate exterior angles. Okay, but because we can conclude that 3 is a vertical angle, and that angle 3 and angle 5 are supplementary, we can use our same side interior angles postulate, converse postulate, to answer our question. Okay, so now we are going to look at number 3, angle 1 and angle 4. So I'm going to focus on angle 1 and angle 4. It says angle 1 is equal to angle 4, which is 104 degrees. Now, thinking about our converse postulates, do we have a converse postulate that allows us to know that these two lines, L and M, are parallel? And the answer to this is no. Okay? We do know and we do understand that 1 and 4 are vertical angles. However, if we know the if-then statement on the vertical angles is going to be if 1 is equal to angle 4, then 1 and 4 are vertical angles. On the converse of the vertical angles, if 1 and 4 are vertical angles, then we know angle 1 and angle 4 are congruent. So be careful on that. We do not have enough information. It does not connect line L to line M. So do we have enough information? No, not yet. Okay, so we can't conclude that line L and line M are parallel. Okay, any questions? Remember to ask me tomorrow. Alright, so what we have here is this is our last lesson of the day. And what I want you to do is I want you to pause. And when you pause, I want you to try these different problems. Now, it does say find the value of x so that L is going to be parallel to M. When you do that, you are basically assuming that L is parallel to M, and we want to make it so that x allows us to find values that tell us that L is congruent to M. Okay, so pause now, give these a shot. If you're not quite sure on how to do these problems, just wait, and I'll be with you in just a second. Alright, so this says angle 4 is going to be equal to 70 degrees. Okay, so I'm going to cross out 4 here, 70 degrees. Then angle 6 is going to be known as 2x. Now, we know that if you look at those two angles and we assume that L is going to be parallel to M, we need to know that 4 and 6 are same side interior angles. We know they're same side interior angles, but if we assume that L and M are parallel, we need to assume that 70, angle 4, and angle 6 are supplementary. So what we have to do is we have to take 70 plus 2x is equal to 180. From here, we do our algebraic equations and go through the steps. We now have 2x is equal to 110. Divide by 2 on each side, and our answer is x is equal to 55 degrees. Okay, we have x is equal to 55 degrees. If we plug that back into x, angle 6 is going to equal to 110 degrees. Now, that's not the question that we want, or that we are answering, but we are solving for x. Okay, same thing on the bottom one. Okay, notice that it says angle 1, and I'm going to erase here. Angle 1 is going to be equal to 114 degrees. This is 114. And angle 5 is equal to 11x minus 7. It's broken up there. This should have a 7 here. This is down there. Okay, so we have 11x minus 7. So now, what type of angles are angle 1 and angle 5 if L and M are parallel? Those are corresponding angles, and we know corresponding angles, if L and M are parallel, that they are congruent. So 11x minus 7 is equal to 114 degrees. We're going to do our algebraic equation and go through our algebraic steps. Add 7 to each side. We now have 11x is equal to 121. Divide by 11 again, and x is equal to 11. Okay, x is equal to 11. That tells me that if I plug in 11 in for this x here and subtract 7 from it, we would get 114 degrees. Okay, so on these types of problems where it says find the value of x so that L is parallel to M, you're basically assuming that L is parallel to M. And what you have to do is you have to come up with the correct valuation of x to make them parallel. Okay, awesome. That is all we have for today. Have a great day, and I will see you tomorrow. Remember, any questions that you have on 3.5, let me know and I can answer them. Have a good day.